Hi everybody, and thanks for joining us for another episode of What's Up with Nick and Chuck. I'm Chuck Schwartz, the East Coast Director of Business Development.
And hi, I'm Nick Ralph. I'm the Medical Business Development Director for the West Coast. Today, on our episode of What's Up with Nick and Chuck, we're going to be talking about powder coat testing. And with us today, we have two special guests, Mark Collins, HUI's Applications Engineer, along with Pete Pingel, Technical Sales for Hentzen Coatings. Welcome, guys.
Great. Peter is kind of a special guest because not only is he with Hentzen Coatings, manufacturer of powder that we use, Pete actually used to run our paint line here for several years. How many years did you run the paint line for us, Pete?
I did it for about 9 years, almost 10 years.
And now you're with Hentzen Coatings?
That is correct.
Nice. So, Pete, why don't you give us a brief intro to what the difference is between powder coating, which we do here at HUI, and wet paint?
Well, powder coating is basically an application of a dry material is that applied electrostatically and then cured to the substrate. Wet coating is using a liquid, typically a single component or two component paint that is applied to coating, which allows the coating to be done, but it's cured through a chemical reaction most of the time. So powder is basically more times a quicker, more efficient process.
And would it be fair to say that powder coating is basically applying a layer of plastic over your part?
Yes, correct. They're thermoset plastics that cure in the oven when they hit a certain temperature, and there's a chemical reaction that happens that allows the coating to form a film that adheres to the substrate.
So a lot of people think that their powder is their first defense as far as corrosion, but that's not necessarily true, is it?
Correct. It is the first defense, but the defense actually is the marriage between the powder coating film, the pretreatment system, and also then the substrate. So the three of them have to work together in order to get good corrosion.
So is it fair to say that it's very important to get good adhesion, a good application of the powder in order to get good corrosion?
Yeah, if you want good corrosion, you're going to need to have a good coating, number one. You're going to have good substrate to apply that coating to, and then you also have to have a good pretreatment system in between the substrate and the coating to achieve the maximum corrosion level that you're looking to achieve. And sometimes, depending on where those parts are going to be exposed to, your corrosion requirements could differ.
Okay. So I have a list of tests that we do here at HUI. These are tests that are done at the application or
Yep.
right after. And so our first one is the mill thickness test. What is that, Peter?
So a mill thickness test measures the actual thickness of the coating on the substrate. It's really kind of the most important test because what it does is most manufacturers have a recommended film build. And that recommended film build is determined to achieve the maximum physical requirements that the coating needs to achieve, and also to help achieve the corrosion requirements that the end customer is looking for. So it can be done, most of the time it's done after the coating has been cured, and you want to check your film builds on a regular basis on every paint line that's run numerous times throughout the shift. And there's also other ways of checking film build, which can be done prior to cure using an uncured powder thickness gauge, which gives you a rough estimate what the coating thickness will be.
So you could tell the painters, hey, you need to put it on a little thicker or you're too heavy, that sort of thing?
Correct. Yeah, I can provide some feedback. It's like I said, it's an estimate. It's never really 100% accurate, but at least it gives you a ballpark idea of where they're at from the application standpoint.
The second test I have here is a gloss. Measure gloss.
So you measure gloss using a gloss meter, and what the gloss reading is typically gloss units, which is basically a percentage of light reflectance off of the coating. So it's always good to understand where your gloss reading is because most manufacturers have a recommended range where you need to be at. And typically, if your gloss is out of range, it can tell you that there's something wrong in your system. So either your parts are being overbaked, which means your gloss will drop, or sometimes they're underbaked, which means your gloss typically will be higher than the recommended gloss range is.
Okay. The next test I have is impact test. How is an impact test performed?
When an impact test is performed, you take sample substrate with the coating on it, place it underneath a cylinder that has a weight, and that weight is dropped into the test panel. And there's an impact test. Typically, it's a 2-pound weight, and it's dropped at different weights to get up all the way up to 160 inch-pounds. So the coating then will take that impact, and you look at the coating both on the front side and back side. So we have an indirect measurement and a direct measurement and an indirect measurement, and you check to see if the coating cracks on either side.
So if I remember correctly, we'll get a tech sheet from Hentzen, and it will have the height of the weight that's supposed to drop. Is that correct?
It won't necessarily have the height. What it would have is the weight. So depending on the test apparatus you're using, if you have a 1-pound weight in it or a 2-pound weight in it, the height could vary, but it would still tell you typically on the column, it'll tell you 40 inch-pounds, 80 inch-pounds, 100 inch-pounds. And the technical bulletins that we would provide would tell you what that coating should pass.
Right.
So if it tells you should pass 100 inch-pounds direct and indirect, that means if you have a panel that's painted on both sides and you put it into the testing apparatus, drop it at 100 inch-pounds, the paint should not crack front side or back side of the panel.
I know that we had a project once, Pete, where you helped me out. And, I don't remember the chemistry of the powder, but we had a certain powder that if it's too thick, it becomes brittle. And I know that it showed up on the impact test.
Yeah, correct. So some coatings will have more flexibility than others, and some coatings, if they're out of the recommended film range, as we were talking earlier about mill thickness, will lose its flexibility if the coating gets too thick or if it's too thin, because you don't have a good film build that it's not going to flex the way it should.
Right. All right. What about the Mandrel bend test?
So the Mandrel bend test tests the elongation and flexibility of the coating. So like when we talked about impact testing is more of a direct, immediate force, where Mandrel bend testing is more of a drawn out pull of the coating and the durability and flexibility of the coating over either a cylindrical or a conical tube.
And what does a fail look like? If I do the test, how do I know that my
when the coating starts to stretch, if it starts to crack. So essentially you're looking for cracks.
Okay.
So Pete, is there any correlation between, or like when we're seeing with customers and they're picking out their color choices for on the carts, is there anything in terms of flexibility in the powder that so that you're using the right powder for the right either gauge material or the right usage of how the part or the piece of equipment is going to be used? You know, because you talked about the durability, or like on the impact test or on the Mandrel test, where if it flexes, it'll crack or get brittle. Is there anything that we need to do with our customer base to help them understand formulas on what goes or what powders to use for something that's more flexible or less flexible?
Yeah, so the flexibility comes into play essentially with the raw materials used in the coating. So different chemistries have better flexibility than others. So sometimes if you're looking on a highly flexible coating, you may give up a different characteristic of the coating. So if you have a product, essentially just say in the medical field, where you want high chemical resistance, typically a coating that has high chemical resistance is highly cross-linked and has less flexibility.
So Pete, is there any correlation between, or like when we're seeing with customers and they're picking out their color choices for on the carts, is there anything in terms of flexibility in the powder that so that you're using the right powder for the right either gauge material or the right usage of how the part or the piece of equipment is going to be used? You know, because you talked about the durability, or like on the impact test or on the Mandrel test, where if it flexes, it'll crack or get brittle. Is there anything that we need to do with our customer base to help them understand formulas on what goes or what powders to use for something that's more flexible or less flexible?
Yeah, so the flexibility comes into play essentially with the raw materials used in the coating. So different chemistries have better flexibility than others. So sometimes if you're looking on a highly flexible coating, you may give up a different characteristic of the coating. So if you have a product essentially just say in the medical field where you want high chemical resistance, typically a coating that has high chemical resistance is highly cross-linked and has less flexibility. So if you are using a medical cart, for example, that gets banged around a lot and they have issues with paint cracking on the side of them, but they don't have a lot of chemical resistant requirements, that opens up a opening to different types of coatings compared to a coating where they have high chemical requirements from a resistance standpoint, then they will have to give up some of that flexibility in order to achieve the chemical resistance.
Okay.
So an extreme case would be if you're powder coating a spring, a compression spring.
Correct.
All right. Let's see. The next test I have on my list is the Crosshatch Test. What is that?
So a crosshatch test is basically an adhesion test. So it can be done, the most common way of doing it is basically cutting a grid into the coating, and it can be done two different ways, either using a template and a razor blade, cutting a series of lines and then doing another set of lines that cross over and make a series of squares, and then you apply tape over it and you pull back, and depending on the amount of coating that lifts up tells you what kind of adhesion you have with this coating to the substrate.
Okay. So it's literally like a tic-tac-toe board, put a piece of tape on it, and then tear it. Okay.
Correct.
All right. What about the pencil hardness test?
So pencil hardness test is a test essentially that tells you the hardness and the gouge resistance of the coating. So there's a series of pencil leads and a hardness scale that you're pushed into the coating at a 45-degree angle, and the pencil hardness that does not leave a mark or gouge the coating essentially tells you the hardness of the coating.
Okay. So that's, I mean, literally that is a pencil lead test, like the different types of lead I used back in college, drawing things.
Correct. Yeah. So like the pencil hardness scale goes from 6B to 6H, and typically most powder coatings pencil hardness rate around a 2H level.
Okay. The last test I have on my list is the color match test. How is that performed?
There's two ways of doing color matching. Number one, from a production standpoint, typically be a visual match where you actually visually just look at it and to the naked eye. What does it look like? Does it look like it's match? Usually you have a standard that's predetermined and your batch panels are looked at it and measured. The important thing to understand is when you're doing a color match, you have to understand the color in the light source that's required. So there's numerous light sources. So if you have a specific product that needs to be measured or visually checked in D65, which is sunlight, make sure that you're visually looking at it then. Or if cool white fluorescence, another primary light source, then you have to make sure you're doing a visual check in cool white fluorescent, because the light source can change the way the color is viewed. Another way of doing it is a color spectrometer, where you can take the actual panel and predetermine the standard basically in the light sphere, and it'll give it an LEB value. And you do is you take then batch panels and you measure it against the standard, and the distance in the color sphere between those two is measured in a delta E. So the delta E should be typically 1 to maybe 1.5 at the most from the standard, most likely under 1 delta E from the standard that's stored.
I know that I've run into problems before with when the gloss is off, the color does not look the same to me. So we might put it in the spectrometer, and the spectrometer is telling us, yeah, you have a really small delta E. But when I look at them, I'm just like, they don't even look the same color. But everyone always tells me it's because the gloss is different.
Yeah, the gloss can make it look different to the human eye. So it's even most spectrometers will tell you what the gloss is reading when you measure the color on it.
Okay. All right. So all of those tests we talked about so far are tests that are basically done on the line, right? Right after you paint it. What kind of tests are there that are done afterwards to measure how good a corrosion resistance you have? I know that you have done a detergent chemical test for us in the past.
Correct.
What kind of test is that?
Essentially what it is predetermined detergent. There's an ASTM that for the chemical makeup of it. And those, you take a treated panel that's powder coated and you basically submerge it in the detergent testing, and you basically watch over a period of time for any sort of blistering or any sort of degradation to the coating.
Okay. What other tests are there like that?
Well, the most common is when we talked about corrosion earlier, salt spray. Salt spray testing is a common test where panels are put into a salt fog chamber and submitted to a duration of exposure to a salt fog, 500 hours, 1,000 hours. 1,000 hours is the most common. And then the panels have a scribe in them, and over time the corrosion starts. And then you basically measure that scribe in the corrosion, and you basically use it as a comparative test, as a base, usually a baseline or a score that you have to meet or beat to determine what kind of corrosion results you have.
I know currently have a salt spray test going on at Hentzen. Is that true?
That is true. Correct.
Do you know how those results are coming out?
I have not checked myself because the next evaluation point is, I believe, a week from now, which is 500 hours, which is essentially around 4 weeks, and it's going out 1,000 hours, which is so it's an 8-week test.
Sure. Okay. Let's see. That pretty much covers most of my list. What else is out there? What trends do you see in the industry? Is there anything interesting that we haven't really covered?
One test that probably could be implemented on the line that most places should do is Solvent Rub Test. Basically tells you the amount of cure the powder coatings have. That's a very good test to give you feedback if the powder coating is cured. Other things we're seeing out in the marketplace with basically COVID situation we're in is a lot of people are asking about antimicrobial coatings, which we can manufacture antimicrobial coatings that have been known to deter about 99.5 up to 99.9% of microbes.
Is that an expensive thing to add to your powder?
There's a cost associated, but I mean, it's something we can do for anybody. I wouldn't say it's overly expensive.
Well, thanks a lot for your time today, Pete. We greatly appreciate it. I think that on the next upcoming episode, what we'll do is take and run through with our viewers each of these tests that we conduct here at HUI, and that way we can show you how those tests are conducted and the results.
Again, we greatly appreciate you coming in or joining us today, Pete, even though you couldn't be here today.
Yeah, no, I think I appreciate you guys asking me. Seriously, it's pretty interesting that you guys do this. It's pretty entertaining and it's pretty neat. So I think it's pretty cool, a little different.
Well, thank you again. And thanks, Mark, for putting this all together and organizing this. And for our viewers, tune in next time for another episode of What's Up with Nick and Chuck.
Thanks a lot for watching, and take care.